Hello world. My name is Stefan Pölz, aka Flashover, and today we have a should turn off the volume of my monitor. Today we're gonna have a follow-up session from the last one, where we ended with perhaps benchmarking and or profiling a specific part in source generators, and this will be our topic for today. We will have a brief overlook what we did last time, the analyzer that we built, and then reiterate an issue where I just wasn't sure how to solve it yet and if that is a performant way in the first place. So we will reiterate the problem, and then we will do some benchmarking with the infamous benchmark.net. So we will set up how we can benchmark our Roslyn generators, both source generators and incremental generators. And when we have then figured out if this one solution that we still want to try is actually yields a good performance or not, we will also look into profiling with both Visual Studio and with a combination of Writer and dot trace. Now, full disclaimer, I have little experience with profiling in general and pretty much no experience with profiling Roslyn components in particular. So this will be a bit of an exploratory session. Um, Most likely, I will also not be doing 3 hours today, perhaps a bit of a shorter session because, well, in the future, I may change the format quite a little bit, do more frequent streams, but a little bit shorter. And also, I will be doing a new format, which will be potentially co-streaming with a peer of mine, but we're still sorting out the details. So perhaps there is something in store next month after NDC London. So this is what I'm quite excited about. Perhaps let's get this out of the way. So I will be next week in London at the NDC, and also on Monday we'll have a talk about source generators. But there's a lot of great content there. So if you get a chance still, it's not the early bird, but late bird. Perhaps we see each other there. Um, if you find me, then let's have a chat. I would love to talk about Roslyn or other stuff in .NET. Okay, but let's get to the content. So what did we do last time? We have built this time I'm now mainly using Visual Studio again. I'm switching between Visual Studio and Writer, but later on we will also have a look at that Writer, of course, about profiling, which I just tried before the stream for the very first time, if everything is set up correctly. Okay, so what did we do last time? Yes, we have built a generator, the nullable attribute generator. I haven't fully finished this because there is actually a lot of nullable attributes. Let's have a brief look. That's the last session. Where is the link? Reference types. There a nullable reference attributes. There they are. And there's quite a number of nullable attributes, and they are available since .NET Standard 2.1 and .NET Core 3.0. Those are these. And also, no, hold on, I'm those two, the member not null and member not null, when they're available since .NET 5. And so the generator should generate all of these attributes. For now, it's still only generating this one because I wanted to sort out this particular issue that we will have a look at in a second. Before then generating the rest of these. So we'll be generating the allow null attribute if we have either on the CS purge level nullable annotations enabled, or at least at one part in our source code via the nullable directive. And then we will generate all of these attributes if they do not exist yet in the compilation, either through the BCL or perhaps the user may have added them internally themselves already, or perhaps coming from a different package because there is the nullable NuGet package, which is also including those attributes if they are not there yet. Yes. So how do we generate this attribute? So we have an incremental generator. Perhaps I should zoom in a little bit. We have an incremental generator where we do in the initialize, where we set up this incremental pipeline. Then here is the to-do where we're not quite sure about yet, where we tried out last time. How do I show this best? I guess via SharpLab, of course. What else? SharpLab.io. I'm using this almost every day. It's fantastic. And entirely. Let's zoom in. Okay. Via the nullable enable, for example, annotations. We could also enable just warnings or enable both annotations and warnings. And likewise, we could also disable both or disable just the annotations or the warnings and so on and so forth. But how does this look like in Roslyn? If we switch to the syntax tree, we will find that there is a nullable directive okay, I'm not sure, as a trivia in this tree. And we try to find that, but since this is a trivia, we don't get this in the syntactic callback of the incremental generator. And this is what I found out last time. There is something that I don't understand about Roslyn, actually, or didn't before. And yeah, so how to get this trivia is not super trivial, at least to me. Perhaps there's a super elegant solution, but I'm not aware of this just yet. Maybe we'll find this today. And yes, so we tried to find that. We couldn't do it immediately, because if we try to check if this node is indeed the nullable directive trivia, the nullable directive, we'll find it, nullable directive. Name different. Let's have a look. How do we find that? Perhaps via source roslyn.io, or we go to sites of .net. No, sites of .net. So then we can go to the Roslyn.io, Roslyn source.io. Available. Okay. I can't recall. We had some node. Yeah, maybe completion. Okay. Well, we found some node where I thought this was it, but it never resolved to true. So we need to find a different way. Perhaps check the children of all nodes if there is this trivia available. I'm not sure about the performance of these. So let's investigate that. Yes, and once we figured out if we actually want to create it, so the second check is we get now of each node, we also get the, so this is now the other way, we get of each node, get the position of the node, and check within this tree if the nullable context is enabled, which it is if, jump back to SharpLab, if we have either nullable enable annotations here, or if we have enabled it on a CS Proj level. So actually, it would make sense now that I think about it. Okay, I come to this in a second. So this will now check each node if it is within a nullable enabled context. And if it is, we do return this node, otherwise we return null. And all the nulls we will filter out. So here is our syntax provider, and we filter out all the nodes which are null. So we only have the ones which are not null. So we get all the nodes which are actually within a semantic, which in a nullable context. Now that I think about it, is actually then the execute phase. And in the execute phase, we, so perhaps to get the full context, we then also combine the syntax provider with both the compilation and also the parse options. So the parse options we need to find out which language version it is. And the compilation we need to find out whether this type is already existing in the compilation, defined in the BCL or internally by the user or through some other package or dependency. And this is then the full name, the metadata name that we're looking for. So we will try to find in the compilation if this nullable attribute is not null. If it is not null, that means it is there, it's already declared, so we can return, we don't need to generate. But if it is null, we perhaps need to generate. But the second check is if we are either on a compilation level have the nullable context options enabled, at least annotations. So this is when we set it in the CS Proj. If I have a look, I don't think I have it enabled here, but I do have a, let's jump to the folder view. directory.build.props, where is it? There it is. In directory.build.props, we say nullable enable. So this is how we enable both warnings and annotations. We could enable just the warnings or just the annotations. And the enable sets both. And since it's a flag, then we check if the annotations are enabled. We can have a look at this and we see it's either disabled, it's a default, either warnings or annotations or both. This is a flags. So we know 3, combination of 1 and 2. So 3 means both warnings and annotations are enabled. So we check if we have this flag here. Actually, we check if we do not have this flag, because if we do not have annotations enabled, then it's unlikely that the user wants to use those nullable attributes, because yeah, it only makes sense if this is enabled either on a file level or on an entire CSProc level, and this is the check that we do here. And also we check if we found any nodes where we have this enabled. And I believe an already optimization would be to put this up here. I'm not sure if benchmarking could actually confirm that. I'm not sure how expensive this is, but let's find out if we can measure something. Since this is a, what's the term? The short circuiting, the conditional logical combination. Not sure what's the name again. I need to briefly look it up. It's the conditional logical AND. Yeah. And since we could short circuit, so if we don't have any node here, so if we actually found a node here, at least one node which is within a nullable context, then we can already continue and we will never enter this return because we need it regardless of whether it is set on a CSProc level. Move up. Sure. Okay, then we're getting the language version. We see, is this at least C#10, so that we're using file scope namespaces. And then we're gonna build this attribute. So this is basically here the text writer code to assemble this attribute depending on the language version. And at the end, then emit the source in nullable attributes.g.cs, where we then add this source to the compilation. We have also, let's go back to the solution view, build a unit test. Let's run all of them, see if they're indeed green. And I've defined here our unit tests. I refactored them a little bit, where we basically have all the combinations of if we are. So the string that I pass in here is basically then whether we set a nullable preprocessor directive or not. So if we don't have any, but it's enabled on a project level, then we want to generate if it is enabled on a source level, but disabled on a CSProc level. Well, this is actually an irrelevant. This could be disabled or enabled. So another test could be like this. This should also pass. And if we only have the warnings enabled, we do require the annotations. But if you have at least annotations enabled, Wikit can then again disable the annotations. So basically, this should work just as well. If we enable this, quite irrelevant because we already are on the source level. So we set that here, and the nullable context options, they flow into the test setup. So when we follow this test setup code, just for a brief reminder, eventually we will set the nullable annotation, the nullable context options, which will then jump to here. Eventually, when we create the compilation options, then are added to the compilation options. So we say with nullable context options, because per default it's disabled, just as we need to add it. This is why we need to add it explicitly to either the CSProc or via the preprocessor directive, so that we have nullable contexts enabled. Okay, and this is pretty much it. Are the tests green? Yes, they are. And now I would like to benchmark this with benchmark.net. Okay, I did set up a perf project here, called it compatibility.benchmarks, and it's quite empty. It doesn't do a lot. So let's create a benchmark. I usually put all of my generators into the code analysis namespace because everything Roslyn is in the Microsoft code analysis namespace. Let's add a new class here and let's call it the nullable attributes benchmark attributes generator benchmarks. Here we go. I will go peeking at the documentation of benchmark.net. So let's jump to the page. So how is a benchmark set up? Basically, a public class, which then has benchmark attribute on, similar to a unit test, but every benchmark has a benchmark attribute on top of it. And I believe those also need to be public, very similar to tests. Actually, tests don't need to be, no, what is what I learned? No, depending on the framework, they need to be public, but the test class may be static. So let's change this to public. We have our benchmark, public white bytecode benchmark for now, annotated with the benchmark attribute. And yes, now we need some setup. With benchmark.net, we can do a global setup. I think there's also a global, is it tiered on? So the setup is executed once, I believe. Or is it executed every time? Global setup once. Not sure. But everything that is executed in the global setup is not part of the benchmark itself, or not part of the measurement phase of the benchmark. So we can have setup where we need to set up some code. I will go stealing or get myself inspired from all the existing unit test because it's quite similar, if not the same. Let's grab this. So this will be our code. We will have nullable enabled. We have here the nullable attribute. Okay. Perhaps to have a meaningful benchmark, maybe we need to add a little bit more code than just this. Perhaps we add this loop or add a lot of classes. Not sure yet, but this should be the beginning. Now we need to add this code to some benchmark thing, which we first need to build. I will create a folder called I benchmarker. I mentioned the term measure previously. Perhaps I call it measurer. That's a word. Measurers. Oops. And let's have our C# source generator, or just generator. Um, should also have a setup. Then the actual invoke This is where the benchmark will invoke into it. And perhaps later on we also have a teardown where we maybe can inspect something like a test, but yeah, to still confirm that everything is set up as we want it to be, or everything run as we want it to be. And now we need to manually, actually in the setup, let's pass in the code. Now we need to set up this structure, and for that I will go to the source generator cookbook on GitHub. Yes. And because there is a section about testing, there's two ways of testing, either with the packages that we're using in that project or manually via the C# source generator driver. We're going to be using that. So the driver, I'm actually not 100% sure, but I assume that doing a .NET build or perhaps Visual Studio as well uses this generator driver in order to have those sources generated. So we are having here we need to create the generator. Then we're creating a generator driver. We are running the generators. Okay, it's generators, so there may be more than one. And update the compilation. We pass in the compilation. We get a new compilation, of course, because Roslyn is everything in Roslyn is immutable, so the previous input compilation is untouched. And we also get some diagnostics. And we could do some assertions. We can get the one result, and the one result then yields the amount of generated trees. Again, the diagnostics and more stuff. Okay, here we have a method called create compilation. I will just use this. This sounds very promising. Where we create our compilation, we pass in the source code as a syntax tree. Actually, let's have a look at what this is doing. So what do we need? We need an assembly name. We need several, or we may have several syntax trees. We may have metadata references, for example, referencing another project. And we may have some C# compilation options. Binder. That's a type in reflection. Okay. So what are we doing here? So we getting in the code of the user. We are, as metadata, we are using the location of the binder. Since this is something in reflection, I believe this is basically so that we get the assembly of is that the core lib, the .NET core lib, where string and int and such is all included. So we get that. And as an output kind, you have a console application. Perhaps I prefer a library, dynamically linked library. Okay, so we can create our compilation as in the code. Great. So actually creating this compilation, we want to do, this is why we have it in the setup. We don't want to do in the benchmarking or in the measuring phase of the benchmark, because this is some setup. The source generator has no impact on how this compilation is created. So this should be part of the benchmark. The measuring phase should be as limited as only as much. I believe I can't like terminate or boil it down to only the source generator code, but at least as limited to almost only the source generator code. Okay, let's go back to the cookbook. Now it's time to create okay, we need a generator. We could also do that. Perhaps we make this generic, where we say this is a T of incremental generator. Now that I write this, I'm thinking about perhaps later on, maybe a future stream, we could build this in a library, which then supports both incremental generators and also source generators. But for now, let's go with the incremental version exclusively. So say where the T incremental generator is, the I incremental generator. Okay, I have error here. Where is my... Do I do generics wrong? Perhaps I do. Generic constraints, where T is fine. Do I have the wrong interface? Mental generator. Ah, I do not consume the correct package, I assume. Benchmark.net. Okay, I believe we need the correct package. I'll be copying it from the generator. Since we marked it as private assets all, let's use this one. Yes. Okay. Yes, another using is there. Okay. And in the constructor, we made that one. We have our private read-only generator. Generator equals new T. Okay, so that means this must be newable. This must have a parameterless constructor. I believe this is in general a source windows must have this anyway, or every Roslyn component, so that's good. Okay, now we create the compilation and let's jump back to the cookbook. We have the generator, now we can create the driver. So we pass in the generator. Okay, there's a params array of multiple, maybe multiple generators. And this is then the generation. So this is definitely in the invoke phase. So we need the compilation as a member. Field compilation. In our case, that's nullable. Means we must call the setup before. Let's assume that we did that. Assert is not null. So that's the input compilation. Okay. We get an output compilation. Let's not care about this for now. And we get diagnostics. And here we have the driver. So we need the driver as a member as well. Also assume that the setup has been called before. Gonna be convert. And this is the also not a C# generator driver, but a generator driver. Because maybe there are already more generator drivers, or is there only a C# generator driver? Can I F1 the generator driver? Yes, generator driver. Ooh, there's already a Visual Basic generator driver. Cool. So this means we can also generate Visual Basic code? I would assume so. I need to give that a try in the future. That would mean there's also a. So I only have the C sharp dependency installed as NuGet package, but there also must be a Visual Basic generator driver. Yeah, actually there is. We saw it. Okay, let's discard these for now. We want explicit type here according to my code style defined in the editor config. Okay. And in the teardown, we could do some assertions. So I will go once more back to the cookbook. I will be copying this, spamming some stuff in here. They're getting the result. I mean, this is used for testing usually. So the example here describes testing. We could still have a bit of a, in my case, I would like to have then also in the teardown phase assert if everything went right. This could be done differently, and also it's super optional if we don't call teardown matter. I would like to have that, so I'll copy all that in here and see if we can do some nice results here. Actually, debug asserts is not good, so we basically need to check and throw exceptions if we do have something in error. So okay, so we do need the diagnostics. Can we actually out diagnostics? Let's do a diagnostics here. Let's also check the compilation. This is the output compilation. Output compilation. Yes. Okay. So let's have an assert method here. Static void assert. We do a condition bool condition if not condition. If the condition false, then we throw for now an invalid equation. Or let's do, perhaps let's have an exception. Or the assertion exception. Yeah. Now with a message. Okay, so we will no debug asserts, but just our assert here. And there were no diagnostics. Okay, assert is empty. There were count or length diagnostics. We expect to have 2 syntax trees. Okay, if the user adds 1, so there must be 2 because we added 1. Perhaps later on we could modelize this, maybe in the framework to allow more than just one source, just very similar than the testing framework from Microsoft. But for now, that's good enough. Expected 2 trees, but found several. Okay, we do have a link count here and here as well, but we are not in a performance critical phase here, so that's fine. And we also, wherever the compilation is added to the source. Okay, so the new compilation should also be output compilation has no errors. Output reported diagnostics. Perhaps later on we could improve this and actually print out the diagnostics which have been found, but for now it should be good enough to just count. Reported several diagnostics. It seems that this is returning an immutable array. Excellent. An analyzer triggers tells me that I should use the length property instead of linking. Excellent. Okay. Then driver may be null. We assume that debug.insert driver is not null, that the invoke method has been called before. Then we get the result. Okay, we enter the trees, connected one, but found generated trees. There's one. There's again diagnostics. Not sure what the difference between this and these are, but it's not so important for now. Okay, we had diagnostics, or let's say one result plotted diagnostics. Then we get result, first result. We check if it's actually the generator that we have been using. Okay, so that's an ice source generator here. I'm not sure how we could assert this because we have actually a incremental generator. Perhaps we could pass our generator to an incremental generator. There is like as source generator, but I'm not sure if this suffices because that just wraps it. This may fail. Generator did not match. I assume we will run in this one. There were again diagnostics. Add diagnostics. Connected on sources found these, and exception is null. Okay. Generator one result yielded an exception. Okay, so that should be good for now. And we'll have some, there is a nullable violation. We assume that the output compilation is not null. Okay. And this may be our setup for the benchmark already. So let's, in the global setup. Okay, now we need to generate, of course. That, how do we do that? Perhaps we could offer a, make this internal and private. Let's offer a public static wait method. Actually, let's do a non-generic version of this. Static class. And let's have the create method here. That means this one is generic. And we return new. Just make this internal. Like so. And need the constraint as well. Okay. This could be a method body. This can be shortened to a target type new expression. Excellent. And now let's have a private read-only measurer equals dot create. We need the using we will be using our nullable attribute generator, which we yes, we declared this internal. So we need to go ahead and make internals visible too. Yes, there it is. So we also want to make our internals visible to the benchmarks project. So after building, we should now be able to control dot this one. We don't, because we need to add the dependency manually. It's already added. Oh, it's just compatibility benchmarks. Okay, I made a mistake. Now we can add a reference. Yes. Okay, let's create this one. Doesn't seem to work. You have it already. What's the issue? Not sure. Let me manually save zero.code analysis, but the using is here. Okay, maybe I still have an issue with the internals visible to fco.compatibility.benchmarks. And this is the name of my project. The name is here. The string matches. Not sure what I'm doing wrong. Okay, I will try to figure this out later. Let's for now generate a public. I'm referring the wrong project. Looks all right. Oh, here is my error. Because I am consuming it as an, here's my, I'm consuming it as a analyzer component. So basically all of this. Have it. Yes. Get internal again. Okay. So this is a mistake I did previously. Okay. So we have our measurer. And now let's set up our measurer with the code at hand. And let's now, bring the benchmark, invoke it. Okay, for benchmark.net, a guidance is that the benchmark method should always return something so that some code optimization doesn't get along and removes something, just to be sure. So we would like to return something in this invoke method. Question is, what should we return? Does it make sense? Return something. Perhaps object. Then we return null. Not sure if this is good. Maybe I'm confusing some guidance now, but let's try to go with that. And also the global cleanup where we would like to up. I have the assertion, but let's do this later. Let's see if we can. Okay, we need something in here. Otherwise, it doesn't compile. Something. Okay, so let's open a. Okay, this may cause problems now. Benchmarking, doing live streaming. Benchmark. .NET Run. Benchmarks are usually run in release mode. I'm now monitoring my CPU stats. Okay, we have a warning. Yeah, since we execute the integration test in release mode and I have warnings as errors in release mode, as not integration test, but benchmarks should be executed with the release configuration. And that I have warnings as errors, I need to get rid of all the warnings. Static for now. And let's run the benchmark. And there are no results. Because could not load file or assembly. Located assembly's manifest definition does not match the assembly's reference. Okay. Okay, now I would like to debug the benchmark. Set a startup project. But usually benchmark.net complains if we try to run it in non-release configuration. Oops, I get the window on my other monitor. What's going on? Yes, so please run it in release mode. However, there is a way, but we need a separate configuration. We did this in a different project, the analyzers project. So I will be getting that from here, performance, benchmarks, program. Yes, we have some code there. Let's actually grab of it. Let's go to our program CS. It's part of the main. Okay. This is basically this code here. So we have that. We can get rid of this. And which C# would use yes, no, we do. Never mind. Okay. So if the debugger is attached, let's get rid of the missing. Okay, we also have different jobs. We're not gonna need this for now. Okay, so we also add. No, let's do that actually. We also run it on different environments. Both .NET Core, .NET 7.7.2. I did this in quite some time ago. So let's also add .NET 7.2 as a target. Let's do .NET 6 for now. We can have a look at the .NET Framework configuration later on. Okay, what are we doing here? We are, if the debugger is attached, so if I hit F5, or yeah, if I run it with the debugger attached, then we create a debug configuration. Otherwise, the release configuration and the debug configuration has debug in process config, and this then allows to actually debug it. Otherwise, we have a release configuration where we use the .NET Core 6 job. We add a couple of columns. We always have the memory diagnoser. So with that, we don't need to manually slap it on the class. We could also have memory diagnoser here, but this does it for us. I also obviously want to have the ASCII doc output, and we fail on error if something validates badly. Okay, so let's try if we can debug now. We should be able to debug now. The window opens on the other screen. But this worked. And we get 9 microseconds. This is, this is too little, I guess. mm. Okay, first of all, why does this fail during we run it? Also, now it worked. That seems to, okay. Did I change anything while having the new setup? No. Okay, but 8 microseconds. Just allocated 4 bytes. Seems too little to me. Are we doing something wrong? So this is the invoke method of our generator, of our measurer. And let's have a look at if this is invoked multiple times. It should be. Bug. We are MF5ing and continuing, and we hit it all over again. Ooh, but let's have a look if we actually go into the generator. Is this now the optimization because it's an incremental generator? And if the that's the thing, I guess. It's an incremental generator, and the incremental generator doesn't generate the source again if nothing changed. And we're not changing anything in our input compilation. The input compilation is exactly the same for each and every one. That would mean the incremental generator is now the evidence that the incremental generator actually works incrementally. I would, oops, that's the wrong generator. To go to the nullable attribute generator. If I do a breakpoint in the execute phase, this should only execute one single time. And okay, we are in the invoke of the measurer. I hit F5. Now we are in the execute phase of the generator. I hit F5. We are now in the second invocation. And I hit F5, but I continue. I do not go back to the generator. Yes. Where it is, there it is. So this is only executed once because we don't change the compilation. Yes. Not sure if this is like cool or a benchmark. I guess not, because we want to measure the performance of the code that we wrote and not of the minus the optimizations that the incremental source generator does, because this is not our domain. This is domain of the incremental generator. So I would claim that we shouldn't do that. So always compile it anew. And I believe now that, let's try that out. What we do in the invocation phase, pass in the invocation, pass in the input compilation, get an output compilation and a diagnostic, and it also returns a new generator driver. And if we discard that, if we not be using that, if we don't assign this result back here, then we may be able to actually invoke this multiple times. I am now because in Roslyn everything is immutable. So if we ignore the return value, nothing is changing. So we should now be hitting the generator, the execution phase multiple times. So we are in the execution phase and again and again. I can now hit continue and somewhere else and continue. Ooh, okay. We are not entering this because we have the nullable attribute already. So I actually want to run this with the .NET Framework um, configuration because .NET Framework doesn't include the nullable attribute yet. Okay, but we saw now so this is now actually hit multiple times. So by discarding the result of the generator driver, we can invoke all over again and we will invoke again and again. So let's try to do that in release mode. Let's have a look at the result. So oh, hello, Matthias. Yes, I was in the zone. Uh, your last day of the NDC Oslo call for papers. Yes, I have a tab open somewhere. I still need to do this just in time. All right. Thanks, Matthias, for tuning in. Now it looks. Now we do a little bit more. Okay, we do now actually have a couple of allocations, and we are running. We have now more work actually to do because we run it every time, but it's still not generating the attribute because we're on .NET Core 6 where this attribute exists already. So now I think it's a good time to add the is it a comma or a semicolon? Semicolon, I believe. Net 472 target as well. And we will add the configuration here. So this should now enable us. Oops, I closed the command line. Yes, Matthias, you waited very patiently. Thank you. I actually did two submissions already, but I'm working on a third one. Let's see if I get this done in time. Matthias writes, it's a good topic about benchmarking source generators. Thank you very much. I appreciate it. I hope I can result with a nice solution. Perhaps then after NDC London, then maybe making a NuGet package out of this, if this proves helpful. .NET Run dash release. And yeah, okay, it is a comma, not a semicolon. What's the issue now? We get hui. Oh, my bad. It is a semicolon. However, I need to do target frameworks. Okay, if I would have used Rider, I will. By the way, Matthias, I will use Rider later on. I'm just not all too familiar with Rider profiling, which I want to check out later on. I would have used Rider, and there would have been a nice check. Actually, I have it open. I should have done this. Go here to what's the thing? Is it how do I get Alt Enter? Probably. I go to the forget it. Properties. Yes. But actually want the properties of the benchmark project. And if I would have then went to here and selected it here, then it would have did it. Then it rather would have fixed it for me. Yes. Okay. So don't do this all too manual too many times. Let's add one more time. Now we have another issue because some analyzer complains about the serializable warning. I believe this is in. I will cheat quickly and disable. No, I will not do that. No. Warnings as errors is always true. No, let's not do that. Let's fix the warning. So this analyzer wants for our measurer here the serialization attribute. Serializable, I believe. Okay, yes, we're almost there. Now we have the issue, since we now multi-target, we must select the framework that we want to build. Let's do Net 472 because if it builds for Net 472, it's very likely building for Net Core 6.0 as well. And this may now just, yes, now we're there. Okay, and this will now take a minute perhaps, and we should then have two results. One result where we run against Net Core, where we have the nullable attribute already, which should again be like 30 milliseconds or microseconds. And then the other result when it runs against .NET Framework, where we do not have the nullable attribute in the BCL. This should then be measurably slower because that attribute is actually generated and we should have significant amount of more allocations. Oops. And we do not. Okay, so it's pretty much the same. But we actually do not. Okay, let's have a look at the. Let's have a look at the actual cleanup phase that I wanted to do. To basically have an assertion if the attribute is actually generated. So if we say measurer dot cleanup, I called it teardown. Okay, I'll fix the naming later on. Now we will call into that and see what's going wrong. If something is going wrong, because we expect that we actually generate an exception was thrown. Okay, so we don't really get the message of the exception. Okay, so I guess we need to debug. Okay, I believe now I need to restart Visual Studio because it doesn't do well with adding target frameworks, obviously. Startup project. I'm in configuration. Let's go back to debug configuration. And I just realized that I opened the wrong solution. Sorry for that. Compatibility, there it is. Yes, there we are. Matthias, if you're still there, have you submitted to the NTC London, NTC Oslo in 2022? Perhaps we have a chance to see each other again. Expected trees. Okay, we expected 2 trees but found 1 with an error. We expected two but found one, so nothing was generated. Okay. I'm wondering how could we, I guess this is difficult. How may we, oh, not yet, but you plan to do so in time. Okay, yes, so just in time. Excellent. Then it's the freshest. This is also my approach. Okay, yeah, so nothing is generated actually. Yeah, because the attribute is there already. That's tough. Now, what's cool about the unit testing framework is that, jump to the unit test, we can actually define, there is this thing called reference assemblies. And we can pass in the reference assemblies that should be used, for example, Net Standard 2.0, Net Coop 2.1. So it's very simple to tell the test runner, which, or test runner is the wrong term, but the test, the, the ad hoc workspace compilation, which is created in memory, which BCL basically should target. But since I'm having a quite manual setup here, I'm not sure if I can quite do that. Because I would assume that in code behind, yeah, actually, then perhaps downloading the reference package. Let's go to GitHub. That's the Roslyn Microsoft.codeanalysis.testing. Yeah, quite unlikely that I'll be able to do that. Oops. Codeanalysis.testing. Here it is. So this would be the reference assemblies. Yeah, package identity. So this is then, are they then going to NuGet? Would appear so. Then download the reference assemblies from NuGet. Whew, okay. Could I reuse that? Because I thought I'm able to build that. I guess we could use the testing setup, but then then maybe our measurements may be not reliable because there is a lot of testing code that will be executed and not only the not only the generator itself. So okay. I guess this is a bit of a dead end for me right now. Doubt that I'm will be able to fix this in an hour. Okay, I need to do a bit of research on how to nicely have something similar, or perhaps could derive from that, but without having all the testing, without using the testing, using the infrastructure, but not the actual testing invocation to have a reliable benchmark. Okay, but perhaps for this test, it would make sense if we say, hey, only run this one-net framework. Perhaps there is like an attribute to add like a job attribute and say, this is only for, I'm not totally guessing by the way, for net framework 472. But for simplicity's sake, I will for now. remove that job. I hope this basically suffices. No, we still expected 2 trees, but found only 1, so still nothing is generated. Because probably... Hmm. Yeah, this is only... There's nothing generated. Perhaps if we try to... No, this time I'll be doing wider. Properties. Remove the net 6 target, perhaps. And add a... Yeah. Perhaps this helps us out. Let's find out. Object reference not set. Ooh, it seems so. So we... Ooh, okay. It's so we passed this. Well, then in the setup... Okay, perhaps I find something smarter later on to still be able to target more frameworks and not like the lowest, but maybe load this reference assembly. Okay, there needs to be some improvement. But as a starter, this is all right. And we now object reference is an instance of the object because we driver. I guess because, okay, now we need to, for the teardown phase, run this just one more time. And here. So let's discard those here completely. And we have both the output completion and the diagnostics only where we need them. Here. Okay. And we actually then do not discard this result, but use it. Okay, so let's try that. Assertion generator did not match. Yes, okay, the generator did not match because we are wrapping it in the S source generator. Because this is now, I believe this S source generator is wrapping it in a wrapper. Let's find out. Let's go to the Roslyn source code. Oops, that's the cookbook. There it is. S source generator, and it wraps it in an incremental generator wrapper. Okay, so that's an incremental generator wrapper. That type is unfortunately internal. So we can't really... Okay. I will... Perhaps I get this assertion on later. And now I will know it to do. Try to assert that the generator in use is as expected. Okay. Now, actually, what I now start thinking is that this assertion or this teardown that we actually do at the end now actually helped figuring out that we don't, that we weren't actually generating something, and now we have 218 milliseconds. This sounds more reasonable. So it seems that we are now actually doing work, and we are asserting that we actually have no diagnostics, no warnings, no errors. Hmm, not sure if warnings would be reported, but I should have a look at this as well. To do well, diagnostics should actually, yes, diagnostic includes all of them, info, all the severities. So we have no diagnostics, no. There is only one. There is one exactly one generated source. Okay, so now we can run it in release mode. Yes, and have a look at how we are performing. And I guess now we have a. I guess now we have a benchmark. Now we can benchmark our source generator code. What kind of topics did you submit? Koch is asking. You want to guess? It's something about generators. And another topic I'm tinkering currently about is immutability. Um, Especially, we're trying to get in all the new stuff with record classes and the difference between read-only and non-read-only record structs. And immutable, since it's also connected to Roslyn, immutable collections and yeah, everything immutable in C# and .NET. And here now we have a result. We have something allocated. We have 53 microseconds. So we have our generator, our analyzer, our benchmark. Now we could compare that against something else. So I'm storing that in a. Actually, let's just keep this open and open another session later on. Let's hit Control. Not Control N, just the plus here. Another in there. On the release. Okay. Next. To have a look at the code, actually. Change something in the code and see if it if the performance is better or not. The thing I have somewhere to do. There is the to do. Yes. We have a to do there. So let's find out. Perhaps we should generate a little bit more code. Yes, we should. So let's jump back to the benchmark here one more time. Maybe let's generate more code. How could we do that? Let's have code here and let's. How could you quick do this? String builder. I want to generate a lot of classes. String builder. String builder. Should be in system text. Yes. And we want to add 1,000 classes. So let's do a static string generate class, a local function where we do return. This will be our basically where we return verbatim string, interpolated verbatim string of this and pass in an index. We will be using the index for the class name so that we do not create multiple classes with the same name and cause compilation errors. And then we will append generate class I. Let's see if this is actually code. Yes. And then we pass in, did we remove, there's the setup. Do not pass in the code, but we pass in the builder.toString. Let's do a debug if it actually creates a lot of code. We should have now 1,000 classes in there. Yeah, so we have class 240 and so on and so forth. There is now 1,000 classes starting from 0. Excellent. Okay, let's see if this. Okay, expected trees, but found one. Why does it not generate again? Ah, yes, 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 yes. Because it doesn't generate now, because I didn't add this initial code, because we are expecting the nullable enable. Without that, we are not generating any code. So that's actually as expected. We pass in this initial code, and now this should pass. Now this should not pass, but run through. Here it looks good. Okay, now we have much more code. Now I guess it's more reasonable, more realistic, let's say, because I thought that there is only one class in the compilation for a generator. There may be more. So there's now a lot more to analyze and to uh, to analyze in the both the syntactic and the semantic callbacks of the syntax provider. And this should be now our baseline. Then we change a bit of code and see if we have improved it. And if we did, then we use this result, this code, and if we don't, then we revert to the old back. Now we see, now we're in the milliseconds area, no longer in the nanoseconds area. We allocated 13 megabytes. Okay, that's a lot. It's actually a lot. But now we have something to improve. And then we jump to profiling. That's the very end. Let's here. Yes. Okay. We wanted to try if it makes a difference if we move this up. So we changed code. That means, of course, we need to run our tests. I have a compilation error. Forgot a brace, a closing. No, it's not a brace, it's a parenthesis here. Yes, all the tests are green, so we can now do the benchmark. Okay. We keep that result. I do it in the diff in the other tab. .NET 1. Oops. My typical typo. This is like my most do this typo all the time. .ent rather than .NET. I think I do this just as many times as I use sharplab.io. And let's see if this changes something. I guess what's also interesting to keep in mind, if because I'm streaming on the side, this is not the best setup to have a thorough benchmarking session. It should be, I think there is a lot of articles on what the best setup is. And there seems to be a difference, isn't it? Oh no, barely. Okay, there is nothing really measurable. However, we spent more time in generation. Not sure if this is actually something because of the code or not. Let's run it one more time. Would you like to clean up my source generator in Nuke at some point? Matkoch writes. Yes, definitely. We're at some point maybe in June. I would love to. Remind me in June. I would love to. And perhaps we could then also nukify the source generator project, because there is way too much manual stuff going on, isn't it? I think if I remember, I think I told you once. Yeah, it's somewhere on my agenda. But this would be then, yeah, for the next. Sure. Oh yes, it would be sweet. For a new format to have more cooperative streaming. Um, okay, if we run it again, we do not have the same time spent in the generation um, collections. So okay, I believe there is nothing, there is no notable difference. So this doesn't really matter. So this is why I keep it as it was. And the other thing I wanted to check if we can do a semantic check here, because we are checking here every node, the location. We get the location of every node and check if it's in a in a nullable context, which means that we build up quite an array here. So this array here that we return from this provider is this immutable array here, then is quite big, I would assume. Actually, let's find out. We run the benchmark in debug mode to hit the breakpoint, and we have 27,000 nodes in here. Okay, yeah, that's a lot. This may explain. Does this perhaps explain the allocations? That's 13 megabytes perhaps. So for a huge solution, I believe this generator is, as it is, not suited at all. Okay, so we need to do something smarter here. And what I would like to find out if we can have here a check. If this node has, let's jump back to SharpLab. SharpLab, yes, has this nullable directive trivia. By the way, what we could also use, a feature of Visual Studio is that I rarely use, sometimes. We have nullable enable. Here we could also have the syntax visualizer. If you install the Roslyn SDK, Visual Studio installer, then we can have a look at the syntax tree here as well. However, it's sometimes a bit flaky, then I need to click around. Yes, there it is. So we see here basically the same that SharpLab.io puts. And now we want to find out if we find this nullable directive trivia in the syntactic check. I mean, it's quite difficult to make them work in all IDEs. It's very much understand how great the template is. Not sure which template you mean. I mean, like a source generator template that you could create with, for example, .NET New, because I built that very same thing. But it doesn't have benchmarking included yet. Once I figured out how it works, then I will update that template as well. So does this mean we need to check every node? Because it doesn't necessarily need to be, here it is within the namespace keyword, but what if the user writes it up here? Then it's in a using keyword, or if they write it like anywhere in the source file, then it's in the return keyword. So you need to check all the trivia of a node. Okay, I am not, yes, that's what I mean. So actually, perhaps I showed it because we added that right now. FC templates, updated my template package to also have a source generator. I also wrote some documentation, yay. So via the fco.templates NuGet package, if you install it, you can then say .NET New Roslyn generator. Per default, you get a 4.0 incremental generator, but you could also select a 3.8 source generator if you want. Select a testing framework if you prefer MS Test or NUnit or XUnit. And then you get a source generator project with a source generator and tests, both integration tests and unit tests with that. And I would like to upgrade this in the future with benchmarking and profiling as well. Once I figure out how this correctly works. So how can we find out from the node trivia? We can get the descendant trivia, a list of all the trivia associated with the descendant nodes and tokens. There's a find trivia. Get annotated trivia, annotation kind. Leading trivia. Perhaps do a bit of Googling or Binging or Roslyn find preprocessor directive trivia in node or tree. I haven't played with Verify just yet. It's on my to-do list, and I can imagine that it works very well with source generators to have like a diff, to have a visual diff of what you expected to be generated and what was actually generated. It's not on my. I perhaps stream about it sometime and then also add it optionally to the template. It's on my list, but I haven't played with it just yet, I'm afraid. But thanks for the hint. This, I guess, now pushes it in the list a bit upwards. Mm, mm. Okay, perhaps I have a look at this later on, bit off stream, how to, what later on, after conference, how to do this. I will try something explorative. Because I actually don't know what a structured trivia is. I'm too little familiar with trivias. Perhaps we get the descendant trivia, which is an enumerable of syntax trivia. Let's see what this yields. Is this a method? Is this a property? Method. Let's have a look at what this yields. There is a nullable directive trivia. But I guess iterating all of these seems also quite expensive. But let's give it a try. Any? Static trivia. That's a struct, isn't it? So we can't do an is check. Can't do a meaningful is check here. How do I find out what trivia that is? Okay, I should have inspected it more thoroughly. Inspecting. Perhaps we rename the cleanup into inspect. Job. Should I do like a string? This doesn't sound quite too efficient. Well, there is syntax trivia, like a like a kind. I was hoping there's something like a syntax trivia kind that we could check. And now my source link gave up. Not mine, but Visual Studios. Okay. There is a raw kind. Syntax token. Annotation. An annotation kind. Annotation. Something like a well-known annotation kind list. Okay, I'm guessing way too much here. I'll do one more Google search to find if we Roslyn trivia kind. Check. Syntax kind. Syntax kind. Okay, syntax kind has trivias. Do perhaps a preprocessor trivia? Ooh, preprocessing message trivia. Okay, there is this war kind. Let's find some node dot. Okay, one more debugging session. Did I break it? Yes, I did. Let's do a wait to make it easier for the watch tool. Okay, the war kind is 9505. 9505. And if we go to syntax kind, 9505. Nullable directive trivia. Ooh, okay. Perhaps. Perhaps. Static trivia. If trivia is kind, where we check if this is of this kind. Perhaps. And if we have any. Oops. I'm getting. Okay, let's close the syntax visualizer. That. If it is. Oh, I didn't do an any. Yes, any. Well, I guess we would do a naive loop, perhaps, then we could void the link. Perhaps we should do that. But I don't want to dualize it to a full array. Maybe link is actually the correct choice here. Well, I could manually loop move next over the that's, I guess, then a later optimization. Okay, and if we have any, that would mean that we can return but I'm not sure if this is actually all right, because the issue here now is that would be passing only those which have. No, actually, that's cool. Cool. Otherwise, return false. which would mean we perhaps don't need this one. And we just return context.node here. So if we have any, okay, I'm not done. We only know that we have a nullable directive trivia here at our hand. Let's see if this is actually, if we actually have any test that passes there. Now it's time to go back to the unit tests. I'm really glad I'm having these. Let's run one of them. Hope we will be entering this. Yes, please. No, we don't. Maybe I executed the wrong one. Because this one doesn't have a trivia. This one has a trivia. Yes! Okay. Oh, you're infected by my laughing. This is very, very charming of you to say. Thank you. uh, okay, so we now know we have a nullable directive trivia. That's sweet, but we do not know yet what this trivia is actually stating, if it is nullable enable or something. Question is, how can we now? Perhaps we wanna. We need to do more checking on this trivia. If it is that kind, we also want to check if it actually has the annotations enabled. Perhaps we can just check for the string annotations or enable. Would be a bit naive, but may work. The token is a public nullable enable. I was wondering, could we like, how does a different one look like? If we run the test where we have nullable enable annotations, I would need to do a string check. This doesn't sound super efficient either. But let's try. Yes. Also 1055. Maybe like that. I wanted to string it. See what this token has for us in store. Maybe some name. It's public. We have the token. Okay, perhaps the token is helpful. And the token should have a value text, doesn't it? Yes, it does. We could do an ends with check. It's reasonable. Or contains. So let's try if we say, okay, it should be of this kind. And also, should the trivia dot, what was it? Token dot value text. I'm using the value text because that excludes potential verbatim identifiers, such as the at in a variable name. Dot contains. And it must contain either enable. No, it must contain. It must end with enable or end with enable annotations, actually. Okay. And with, let's jump to test this side by side. end with enable, or trivia dot end trivia dot token dot value text and with enable annotations. Now we need some parentheses around this. And ends with also, okay, but not for ends with has a string comparison. Yes. Is that sensitive? I don't know. We say nullable, disable, enable. If I write it like this, no, this seems to be expected. Okay, so it's sensitive. So we can say string comparison dot ordinal. We. It compiles at least. Do the tests still run? Well, I guess they run, but do they still? No one is failing. Hello, 24 minutes. Thanks for joining in. We are currently trying to optimize the performance of an analyzer, and I have a failing test here. So it doesn't generate for the case that we have nullable enable annotations. So then we should return true, and if any does not work out. Value text ends with, but maybe this is not what I expect it to be. So let's put this in a method is nullable context enabled, as in the trivia. I have here a static bool is enabled. We pass in the syntax trivia and put this in a method. I guess there would have been a refactoring for it. Mess up of all the parentheses. There's one too many, isn't it? Okay. Let's see what happens there. The test names are not correctly named. We have which naming style? I guess like a given when then syntax. Trivia dot token dot value text. Okay, this is just using. That's too little. Yeah. Okay, that's too little. Ooh, I'm now at the using keyword. Why am I at the using keyword? That's the wrong. That's not the trivia I was looking for. Ah, so because I get in every trivia. Hold on. Yes. My bad. I think it's the 6th, isn't it? Yes, there it is. Dot token and the value text. It's public. Okay, that's also not. Okay, I'm really way too unfamiliar with trivias. The leading trivia of that is now leading trivia is So now we have the nullable directive trivia. But the text of the nullable directive trivia is not, I expect, already the public keyword from what follows after. Um, okay. Follow up to that just in a second. I'm going to think what I'm doing wrong here. So then the leading trivia is again a trivia list, and there is now one which has the what? Hmm. I will try one more tool. Perhaps this helps me. Naming of the test. This case is not named correctly. At least the two last. I'm afraid stand it. I think at least. I'm afraid not sure what you mean. Okay, I'm not really having the given when then syntax here, so given we have the okay, I would actually need to split those tests up to name them properly because I'm really mixing them. And I have multiple assertions here. This is not perfect. I guess this should be a big list of test cases or test. What's the term? Test case datas, where I combine everything, and then I have a separate test where every combinations where there is an allow null attribute, so we don't generate one, and all the cases where there is no nullable attribute, so we do generate one. Improve the naming. Is it not meant to be nullable disable annotations? Enable annotations. Like, do you mean like this case? So in this case, we do have the nullable annotations in source enabled, but not on a CS approach level. So it should still generate this. Very briefly. Okay, so now you say you saw it briefly and you didn't understand it, so I definitely need to refactor these cases. To once. Thanks for the feedback. There's nothing to excuse. It's there is definitely something to improve. All right. Trivia. uh, yeah, I want to use one more tool. Perhaps this helps me out. It's the Roslyn tool called Roslyn Builder, Roslyn Annotator, where we can build up a Roslyn tree. They should match. No, they shouldn't necessarily match. I just try out different combinations. Perhaps this is like I comment these out because they are like the just some combinations. I will need to refactor those combinations to be more readable because it's a combination of if we have the nullable notation in source and what we have on a CS approach level. Okay, perhaps I should have mentioned it somewhere already. Roslyn quota. Yeah, now I remember. Roslyn quota. Yes. So this is basically the other way how we can how we could create the syntax tree in code. So let's basically paste in our benchmark. Oh, let's just briefly write it. We have system, we have enable, we have a public class, and that suffices. And now we can generate the code. And this is how it looks like when we create it manually. And so we do create a here it is. So we have a compilation unit which has usings and it has members and it's on the class. So the class has a trivia list, I guess with a leading trivia of this. Ooh, we could go for the enable keyword, perhaps. And find if the trivia list contains with the nullable directive trivia, and this is a token. Perhaps this helps understand it. Yeah. And if I don't understand it, then I will leave this for a later improvement. Just briefly refactor this. I don't know. And let's see, get from there. Okay, here's our trivia. Our trivia has kind. This is the yes. 9055, that's the null directive thing annotation. And what does get annotations yield? Because I don't know what it is, nothing. Its diagnostics should also be empty. Exploring now what the trivia can do. Patient gets structure, that does. Perhaps what we need. This looks promising at least. We have setting token. This is also of type nullable directive trivia syntax. Maybe this type exists. As a publicly, I hope. And we have a nullable here. We have a hash token. Let's actually call the hash token. Okay. We have the nullable keyword. Okay, okay. And we have, where do we have like the enable or the enable annotations? Part of the parent. Ooh, this is just the nullable itself. So the annotations then must be a child of it. If you get the descendants node from here, no, it doesn't do anything because it's not nodes. ancestors. Child nodes. Empty. Child nodes and tokens. And there we have something. Okay. So child nodes and tokens, maybe one thing. Okay, just child tokens. Only what we need. We get all the child tokens. Okay. One way to try child tokens and contains. Perhaps the contains. Conditions contains directives. Send and nodes should yield empty because it only has tokens and no nodes. To find token. Perhaps we could find tokens, yes. We list the tokens and then do a contains. Let's get text yield. Okay. But I guess we don't want to do a get text and we can avoid the string checking. Is incrementally identical to we. I'm not sure. Okay, there's a lot of stuff for me to learn. It's kind yield. Okay, and then we have some with methods to modify it. Okay, so the get tokens or find tokens seems promiseful from the get structure, but what else do we have? Get structure, type get annotations. There shouldn't be any. Yes, has annotation. Has structure. Has structure should be true. Okay. Perhaps we need to call has structure before we get the structure. Full string. Oops. Okay, this dramatically kills my debugging session. Okay, but let's see what we have so far. We could trivia dot get structure, and the structure has tokens. It's an enable. We could also do find tokens. Also, but find token is requires an okay. Let's get the tokens. And now we need, so they either have the enable or they enable annotations, but not enable warnings. Okay, so they need to have, I guess we need to, well, I believe they are ordered, so we kind of can assume the order, can't we? We iterate these. Okay, now it comes to writing a nice algorithm to detect that. This is not my strength. So what I will write is perhaps not the most efficient, which will again defeat the purpose. Let's try a bool is enabled. Bool has annotations and bool has warnings. And if these syntax tokens is a token, and if the token Um, can I discount that with the keyword, with the enable keyword? Then is enabled is true. If, let's have this. Okay, the super naive code. This may not be the most efficient, but let's find out where this goes to and write something and perhaps have a better solution at a later stage. And if we have the warning keyword, then we warnings. And if we have the annotations keyword, we have annotations. All right. And now at the end, get rid of this, we can return if we have, okay, I write it naive. If we have enabled and actually we don't care about the, if we have enabled, but no, if we have if we have enabled, but if we have annotations, then we return false. But if we have it, anything else actually. So we only need to find if we have both enabled and annotations. No, we need to find the enabled as well. So if we have enabled and annotations, it's false. Otherwise, it's true. And now I'm glad I have some tests. Actually, it's not annotations, it's warnings. If we have warnings, then we return false. So we actually don't care about the annotations, I assume. Not quite. But we are getting there. If we have nullable enable warnings, should return false. We should end here. Are we enabled? Okay, maybe there's something wrong. Oop. Um, so what is the token here? It's the hash token. Then we have the nullable token. We already know that. We have the enable token. Yes, goes to true. Now my debugging session hangs. I'm afraid. Studio hangs. Okay. And now we have the warnings. Aha, is kind is not the warning keyword. Ah, is there a warnings keyword perhaps? There is a warnings keyword. Yes, my bad. This may work. There we go. Okay. Now all the tests are passing. So we now get, we now should not have this insane amount of, what was it before? 27,000 elements in this array, in this immutable array. It should be now significantly less. Yes. Let's find out if this is true. So I'm starting the benchmarking session and we now have just 2 nodes. It's all right. Should be only 1, but 2 is better. Okay, so this may be faster. We'll do benchmark. Perhaps there could be some refactoring here. We have a warning here. This is why we won't be able to get structure may return null. Okay, I guess this is why we need to first check if they have a structure or structure. So we need to do the trivia dot has a structure. This actually should say in the comment returns a returns. No, it doesn't say so, but comment determines whether the structure is structured trivia. get structure, returns the structure. Okay, so if it does not have a structure, we return. But if it has, return false. But if it has, we can do this check, and in that case, we can ignore the warning. And now it should have no warnings, which should enable us to run the benchmark again. Let's open up. Run-c release. I'm curious if this actually increased performance or if it was all in vain. But then we learned a little bit about trivia. In the syntax tree. Okay, now we have, can we do, okay, now I don't know my shortcuts. Terminal, the Windows terminal allows to split view them, but I'm afraid I don't know my shortcuts. So the previous one, we had 16 milliseconds and 13 megabytes of allocation. Now this one has just 5 megabytes of allocation. We reduced that dramatically, but we do have more. We now doubled the amount of runtime. I'm not sure what's better, so it seems to be a trade-off. We allocate significantly less. Now we really need to go into the understanding of benchmark.net, what those Gen 0 allocations here mean. I'm not sure what the dimension of this is. Okay, it actually explains here. It's the GC generations of generation 0 collects per 1,000 operations. So we have 850 Gen 0 allocations. This sounds a lot. Okay. This bad. Sounds bad. 1,000 operations. Okay, I would need to do my research on what those metrics really mean. Okay, we need to go understand those metrics, but just looking at the numbers, it seems that we are slower, but the garbage collector has less work to do significantly. I'm not sure if this is better or not, but I guess this shows how we can benchmark our source generators and then get some numbers out of it. I don't understand the numbers just yet, but here they are. Cool. Now I want to do some profiling. How can we do profiling? This is now where Visual Studio and Rider differs, at least from my experience. And this experience is like 20 minutes. With Visual Studio, when we create a generator, here's a generator project, we can have in the properties, we can set the launch settings, just like in, for example, in ASP.NET Core application, where we can set up if it's using Kestrel host when we debug, or if it's using IIS. And what we could also set here is to set a profile, the debug Roslyn component. I didn't get this to run in Rider. Maybe it works. Maybe I'm doing something wrong. I'm not sure. But we can set this profile and then define a target project. And the target project is the project which should be executed with this generator or with this generator or with this Roslyn component loaded. So if we now set the generator as a startup project, is it? And we do now do a breakpoint. So I have this example project here, which basically is just a .NET 6 console application, which is consuming this generator. And then actually, yeah, what we see here is this is a different generator. It's the is external init generator, where if we target .NET 6, then we see that this is external init is coming from the BCL. But if we target something lower, like let's go to net 472, then this is external init is now source generated. And we see this is now the source generated version is external init. This is now the source generated version that the generator creates because it detects is external init isn't there. I want to generate it. And so basically this project is now launched. If I debug, if I try to debug now the generator project actually, which is not an executable, Visual Studio launches or loads that within this other project and runs it, and something is going wrong. I was expecting now to hit this breakpoint. Hmm. What? Oh, no, no. Yes, because it's not debugging this application, it's actually debugging generator. So what I can do is do a breakpoint in the generator. For example, in here. I can do a breakpoint here. Now in the, where is the execute? Here's the execute. I can do a breakpoint here and we actually now hit this. And we could now utilize this to profile our generator. So let's go to the example. And we change it now to 472. So let's say I want to also generate these nullable annotations. Nullable enable annotations, which should now enable the generator that it actually creates the nullable attribute. We say allow a null attribute, which is in the system.diagnostics something namespace that I always forget, system.diagnostics.code analysis namespace. Now we have the allow null attribute here. Okay, it's not allowed on a method, but if we would do a property, slap it on here. But of course, static because we're in a static class. And this allow null, we see this is not coming from the BCL, but it's again, this is what the generator creates. And we may now profile this. So what we could do now is, I always forget the shortcut because I'm super new to profiling actually. Start a performance profiler. We would like to select CPU usage. We have the startup project is the generator, actually, the generator project selected, but we will load it in this example project. I believe we want to set it to release, just as with benchmarking, and then can launch a profiling session. And let's see if I can make something out of the numbers. I believe I can't, not yet. I have quite a to-do list on some reading docs and some talks and on .NET shows about profiling. And also I've watched a 10 minutes video from the JetBrains team in profiling in wider, but there is so much more for me to discover. And let's have a look. Yeah, I won't be able to make anything out of these numbers actually, but we should see here something. Somewhere we should be able to find our code. The generator code. Okay, so here is actually the execute, and we see the execute is called and color, perhaps green. Does this mean it's called 18 times and it uses 1% of the entire? Yeah, I guess this includes all loading up the Roslyn component and the project and everything. So that's, but this is again, this is a super small project. So this sounds reasonable. And we can, perhaps you can make more out of these numbers than I do. Um, Would perhaps somewhere there should be like this hot path critical thing. Ah, there it is, hot paths. Okay, but most of the time is spent in some system code. So our generator seems to be neglectable in this super small project. We should also be able to modules. Yes. So this is our generator and execute. And here we see some numbers that it's, yeah, quite small. So I guess this should be used in a bigger project to make something out, to get more reasonable numbers and to actually potentially detect some hot paths there. Um, yeah, so I will definitely come back in a future session when I learned more about profiling. Uh, and then perhaps I'm able to explain all of this and actually perhaps find a bottleneck that we could improve. But for now, I really can't, I'm afraid. But in general, that's the physics behind it, basically, to have and I will also then update the template that we built 2 sessions ago, 3 sessions ago, to also hold there's the solution explorer, to hold not sure if samples or an example project, which then the launch settings is targeting, so that we can not only debug, but also profile our source generator. And now, what I promised all the time, I also want to have a look at how this could be done in Rider. So what I showed in Visual Studio, what I didn't get working is to actually now be able to select the generator and have like a similar experience to Visual Studio. But what we can do, because I do have these dot ultimate edition, we also have dot trace here available. And we could, or this is at least, this was my approach, to debug it via a unit test. So there should also be there should always be unit tests, because otherwise can't refactor a generator and improve performance. And what you could do is actually go into a unit test and start a profiling session. So let's start a profiling session with net 472. Yeah, this is what was explained in the video that I watched. I think, if I remember correctly, timeline and tracing is like a little bit faster, but line by line and sampling yields more detailed results. I may be lying here. I will just go with line by line, because I think, if I remember correctly, this may yield the amounts of numbers how often methods or functions are called. And then we have called a snapshot. I think it's why is it like there is a temporary storage this somewhere on the user drive, and we should be able to open that snapshot. Okay, perhaps with .NET, with .trace. I may be doing something wrong here with the setup. I'm now opening .trace on the side. So this opens here. And yeah, I'm afraid I know as little about as in the Visual Studio profiling experience. For now, I will follow this up in a future session in a couple of months when I understand this But there's also like we could understand some hotspots, um, and somewhere is the list where we can sort by namespace. Yes, so we could sort by our. Increase the screen. I hope the zoom level is all right. Where we can group by namespace and see our code analysis. So this is our nullable attributes generator here. There is the execute method, which may be consuming the most of the time. And we see, okay, this method is, I guess it's called 40 times. And we end up actually creating a new source 24 times because I actually executed a series of unit tests. And perhaps we could, yeah, if I would understand this, also make something out of these numbers. User code 8%, that sounds all right. So, but that's just a user code. I guess what's then the most expensive parts, I assume, is calling into the Roslyn methods. So we need to choose the right Roslyn methods to invoke. I would be guessing. I'm guessing here from, but this is what I really like because it basically requires, depending on the point of view, zero setup, because you just need to have a unit test. Which is invoking eventually where we had a source generator driver that we for the benchmarking built manually into our source generator and can do profiling then based on on a unit test. So we can have our different unit tests can then have different scenarios on how we can profile our source generators out of Rider. I will be experimenting with both of these significantly in the future, but yeah, I'm afraid for this session I couldn't accumulate enough know-how. I just got it working. Actually, in the morning, this was working from Rider as well. I was able to open the snapshot and then have a very, very similar view than to the standalone .trace application, but then it was embedded in Rider. Not sure I'm doing something wrong. It worked in the morning. But this is basically it, yeah. Perhaps I would like to try it one more time to invoke a test of the other project. Like this one, profile it. Let's do, previously do that line by line. Let's do a timeline now. I forgot what the difference is. Now the session is finished and can open the snapshot. Perhaps I need to, I think at one point of time I restarted it and then it worked. I really want to show that. -1 time. So let's open the solution again. Here is our snapshots. Yeah, excellent. Now it works. And can, yeah, again, if I would understand what I'm doing here, then we could make something out of this. But where potentially our hot path is, I think you can actually limit the scope here. So if you find the execute method, it is the execute method of the, if I remember correctly from the video that I saw this morning, from the JetBrains team, we can scope to this. No, scope to this goes to the source. Okay, that's really cool. But we can, okay, we can exclude this method. I actually want to only, did not work in the other way. We can exclude methods, but perhaps not like include only this. Merge method occurrences. I'm not, I don't know what I'm trying to find like something which could give like an Jump to source. So this get type of a metadata name seems to, from all of the execute, if I understand, if I read this correctly, from all of the execute, from our execute method, where we actually try to find, where we actually, via the get type of metadata name, actually try to find if this is external init attribute, this is now the other generator, if this is external init attribute is actually existing in the compilation, seems to take 34% of time. So this is significant. So perhaps there would be a way to write the syntactic or the, no, sorry, where is it? This is it. The syntactic check or the semantic check more efficiently to reduce the amount of calls that we put in there. Yes, and generate source code is like 23%. I guess, well, I'm using a string writer here. This would be a constant because perhaps I could optimize performance here. What we see, um, actually, I'm generating two different versions. I'm generating one version for C sharp 10 and above, C sharp 10 and greater, which has nullable, sorry, which has file scope namespaces, and one version for C sharp 9 and below, which does not have file scope namespaces, where we'll be using block scoped namespaces to generate. But the rest is always the same. So perhaps it would be faster to perhaps have these as const, have like a fixed C sharp 10 version as a const and a C sharp 9 version as a const, and then basically only have the check of the language version and then return that const to totally avoid all the string writer, because it is actually, yeah, 23%, it looks like, from all of the execute method. And if we could boil this down to less, it would be great. Yeah. So, but I'm not sure if I'm definitely not sure if I'm interpreting these numbers correctly. This is now what my first naive approach would would kind of tell me how to make use of the profiling session and improve the performance of the analyzer. Sorry, of the generator. Well, technically, I'm correct because the generator is also an analyzer, but that's technicalities. Um, because what we saw earlier, that the one where we actually allocate 13 megabytes when there is 1,000 classes, and I guess 1,000 classes is, yeah, that's like, seems to be a common project. Is quite a lot. Um, I believe. I guess now to get some real numbers, or to get some comparison, my next move would be to compare, what to check out the source generators of the Roslyn team. Okay. On the other hand, I'm not sure if they are comparable, because the Roslyn team, the .NET BCL team, because if you go to source.net, here is three dots. Yes. For example, the regex generator, which is coming in .NET 7. This is quite a bit of code. And not sure if this compares, but like if this generator is performing significantly better than the small one that we wrote, then there is something wrong. So perhaps I get some numbers from these, and also there is way more generators in the .NET ecosystem. The .NET 5, no, .NET 6. .NET 6 includes a logger message generator, which basically emits a simple usage to, so you don't have to manually use the logger message define in order to have high performance logging. And there is also the system text JSON generator. I'm not sure what the name of this is. I try to search for JSON gen. Yeah, there's also a generator for that. And there is, I think there is a toolkit, which is either it was released recently or will be released soon, uh, in 1.0 or it's a stable release, the MVVM toolkit, which has a oops, stop. MVVM toolkit, which has several generators. One generator which creates the iNotify property changed and iNotify property changing for the properties. So you basically only um, generators. Where are they? Let's have a look at GitHub. Git. That's the samples. Hmm. Is it just okay, I'm afraid I can't find it, but it is there somewhere, which has generators around the inode verb change, but also a generator which creates commands for you that you can then bind in your XAML, in your SAML code. And so I will have a look at these and try to find out how they are performing to get some comparison on whether this here is good or really, really, really bad. Yeah, and this is what I wanted to show and explore. Explore would be more precise because I'm super new to that topic. So I will be my next steps is now to get more into profiling, understand what other generators measure too, and also try to make the measurer that we wrote here a bit more powerful to be perhaps able, yeah, fix the to-dos and perhaps to be also able to allow loading of different BCL versions or reference assembly versions to make more yeah to make it more flexible. Not sure if I'm able to do that, but let's see. This will be the next steps to explore from here. All right. I guess this is pretty much it. As always, after the session, every resource that we have explored during this session, I will put in here. We're going to look at how we may benchmark our source generators with benchmark.net and actually wrote our, I called it measurer, perhaps there's a better name for that, so that we really only measure the invocation of the generator, not all the compilations around it, and perhaps later assertions in order to prove that what we did is actually correct. We had a brief look in how we could profile generators out of Visual Studio via the debug Roslyn component launch profile. Perhaps just to show this is also available through the UI. You can go to the generator, hit properties, and I guess under debug and launch the profiles UI, and here it is. So you could also create a new profile and here select the Roslyn component. This is basically what I did initially, and then select the target project which should be launched, and then you get this launch profile. And how we could do it with combination of writer and dot trace. Very simple, and I really love this out of a unit test because I want to have unit tests in the first place, then have different use cases. And you are very welcome, Matthias. I thank you for sticking around so long. And yes, I have to no, I don't have to mention, but I want to mention it one more time. I will be in London next week, perhaps. find me. Perhaps we could have a brief chat. That would be sweet. And I will change a bit the format of this stream, and we'll come up with something new in the next month. Perhaps in the next month. Let's see how it's going because I still have a CFP to submit. Excellent. Then anything left? I guess not. Oops. I wanted now to thank you very much for staying a while and listening. Um, Not exactly sure when the next stream will be because I will be shifting topics a bit, but it will be soon. And with that, I say goodbye and may Roslyn be with you. Thank you very much for joining in.